You've probably seen the chaos of a hurricane on the news, but have you ever wondered how something so powerful starts? It begins with something strangely ordinary: heat, moisture, and a little bit of wind. When the sun warms the ocean's surface, it creates a layer of warm, moist air that rises. This is the first step in the strange and complex dance of a hurricane's birth. As this energy builds, the wind starts to rotate, creating a spinning column of air that can grow into something far more powerful than you'd expect. The key ingredient? A warm ocean, weak wind shear, and enough time for the system to organize. It's like the ocean whispering a secret to the atmosphere. And that's how a hurricane starts, with something as simple as the sun warming the ocean. Now, let's dive deeper into the mechanics of its formation. So, what exactly are we talking about? Let's start by defining the storm itself. A hurricane is a massive, organized system of winds and rain that forms over warm ocean waters. It's like a giant spinning engine fueled by the heat from the sea. These storms have a specific structure. Right at the center is the eye, which is calm and clear. Around it is the eye wall, where the strongest winds and heaviest rain are found. This is where the power of the storm is concentrated. Now, these storms are not just a cloud and wind show. They're driven by a very specific process. Warm, moist air rises from the ocean, creating a low-pressure area below. This pulls in more air, which then spirals inward and upward, feeding the storm's energy. As the storm grows, it starts to rotate due to the Earth's spin, a phenomenon called the Coriolis effect. This rotation gives the storm its characteristic spiral shape and helps it organize into a powerful, self-sustaining system. Finally, when the storm reaches land, it's a different story. The land lacks the warm ocean water that fuels the storm, so it begins to weaken and eventually dissipate. But not before it can bring devastating winds, rain, and storm surges to the shore. You might think hurricanes are just a summer annoyance, but they're actually a powerful reminder of how fragile our coastlines are. They can reshape entire landscapes in hours, turning calm shores into chaos. These storms don't just destroy buildings, they can also disrupt entire ecosystems, uproot forests, and alter the natural flow of rivers and estuaries. The damage isn't just visible, it's often irreversible. Hurricanes also serve as a barometer for climate change. As the planet warms, these storms are getting stronger and more frequent, making it more important than ever to understand their patterns and prepare for them. Understanding hurricanes isn't just about survival. It's about respecting nature's power and taking responsibility for the planet we live on. Knowledge is the first step toward protection and resilience. Let's rewind to the 17th century, when European explorers first started documenting these monstrous storms. They called them hurricanes, but it wasn't until the 1800s that we began to understand their true nature. In 1851, the USS Waltham recorded the first official hurricane wind speeds, marking a turning point in how we measure and predict these storms. By the 1950s, the National Hurricane Center was formed, and satellite technology began giving us real-time views of storms for the first time. Today, we have advanced models, AI forecasts, and global monitoring systems. Yet, the basics of hurricane formation remain rooted in the same ancient patterns of wind and water. Imagine a big, spinning storm in the ocean, like a giant toy top. It starts when warm, moist air rises and cools, making clouds and rain. The storm keeps spinning because the air keeps rising, and the ocean keeps giving it more warm, wet air. It gets bigger and faster, like a giant bicycle wheel. When the storm hits land, it's like a big, wet blanket throwing everything off balance. Trees bend, roofs shake, and the wind howls like a wild animal. But the storm doesn't last forever. It loses its power when the ocean gets cold or the land gets too dry, and it slowly fades away like a dream. To start, we need warm ocean waters, usually above 26.5 degrees Celsius. These waters fuel the storm by evaporating heat into the atmosphere, creating the energy needed for a hurricane to form. This heat and moisture rise. creating unstable air masses. As the air ascends, it cools and condenses, forming towering clouds and releasing latent heat. This is the start of the storm's energy cycle. The rotation of the Earth, known as the Coriolis effect, helps create the spinning motion that will eventually become the hurricane's eye and spiral bands. Finally, a low-pressure system forms at the surface. This is where the storm begins to organize, with air rising at the center and sinking around the edges, creating a feedback loop of energy and rotation. Once the warm ocean waters are in place, the next step is the formation of a tropical disturbance. This is when the ocean's heat fuels rising air, creating a low-pressure area at the surface. This rising warm air cools as it climbs, condensing into clouds and releasing latent heat. That heat warms the surrounding air, causing more air to rise and intensifying the cycle. As this cycle continues, the system starts to rotate due to the Earth's rotation, forming a spinning vortex. This rotation helps organize the storm structure, creating the first signs of a tropical depression. The more organized the system becomes, the stronger the winds and the more intense the rainfall. This is when the storm begins to take on the characteristics of a tropical storm, with sustained winds reaching 39 miles per hour or more. If conditions remain favorable, like warm waters and low wind shear, the storm can continue to intensify, eventually becoming a hurricane with sustained winds of 74 miles per hour or higher. Now, the storm starts to rotate, not just because of the wind, but because of the Earth's spin. This rotation is what gives the hurricane its organized structure and helps it grow stronger. As the rotation tightens, the winds begin to spiral inward, forming bands of clouds and rain that circle the center like a giant spinning top. The rotation also creates a low-pressure area at the center, which pulls in more warm, moist air from the ocean. This is how the storm keeps feeding itself and keeps growing. As the storm continues to spin and intensify, the winds at the center get stronger, and the pressure drops even lower. This is when the hurricane becomes a real force of nature. At the core of every hurricane is a powerful engine of heat and motion, the warm, moist air rising from the ocean's surface, fueling the storm's birth. This air rises, cools, and condenses, releasing latent heat that powers the storm's growth. A cycle that feeds the hurricane like a living, breathing beast. The rotation is subtle at first, but as the storm intensifies, the Coriolis effect kicks in, giving the hurricane its defining spiral shape. That eye is the calmest part of the storm, a region of sinking air and clear skies, where the most intense winds and rain swirl just beyond. As the storm makes landfall, the friction of land and the cooler air disrupt its energy, but not before it leaves a trail of destruction in its wake. Imagine a hurricane is like a giant spinning tea kettle on a stove. The heat from the warm ocean is the fire and the water is the air, getting pushed and pulled by the Earth's rotation. As the kettle heats up, the water starts to swirl, creating a low-pressure center. Just like a hurricane's eye, the steam rises, mimicking the powerful winds that spiral outward. The heat keeps the kettle spinning, just as the Earth's rotation keeps the hurricane spinning. But the kettle can only go so fast before it tips over, like a hurricane losing strength when the ocean cools or winds change. And when the kettle finally stops spinning, the steam rises straight up, like a hurricane's remnants dissipating into the sky. It's a simple, silly way to see the science behind the storm. Before you go, if you enjoyed this, please give it a like and subscribe so you don't miss the next one. And tell us in the comments what you'd like us to make next. We read every single one. Thank you so much for watching. Comment this emoji if you made it to the end.